Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to the Electrical Engineering channel. In this lecture, I will describe you the definition of Stokes theorem and I will also discuss its mathematical form. So, from the previous discussion, we know that the integral form of Ampere's law can be written as I is equal to h dot dl closed line integral. And we also know that I is equal to j dot ds. So j is the volume current density and ds is the surface area. So this is the surface integral and we can compare these two equations 1 and 2, and by comparing these two equations h dot dl closed line integral can be written as j dot ds surface integral, and from the point form of Ampere's law we know that del cross H is equal to J, or curl of H is equal to the volume current density J. So putting this value of J in this expression, we will have H dot dl line integral is equal to del cross H dot ds surface integral, and this is called Stokes theorem, and it can be applied to any vector field. So here the vector field is H, and this theorem can be applied to any vector field, and this theorem only contains one vector field, which is H in this case, and this Stokes theorem is actually the transformation of line integral to the surface integral. So at the left hand side we have the line integral, and at the right hand side we have the surface integral. We can solve an example to further elaborate the Stokes theorem, and in this example I will apply both sides of the Stokes theorem and compare my answer. So in this example, we are given the magnetic field intensity H is equal to 6x by AX minus 3y square AY ampere per meter. This is the mathematical form of the Stokes theorem. And we are given this surface. So X varies from 2 to 5 and Y varies from -1 to 1 in the Z is equal to 0 plane. And we can evaluate both sides of Stokes theorem. So H dot dl closed line integral will be equal to the sum of four integrals, and these four integrals correspond to actually four paths, and those four paths are expressed in the form of a square, right? In this example, practically the path will not be exactly like this, but we can consider this path for the sake of solving this problem with ease and flexibility. Okay, so this is our path 1, and we have considered this as x-axis and this is our y-axis. Since our x varies from 2 to 5, so here we will have x equal to 2, here the x will be equal to 5, again here x is equal to 2 and here x is equal to 5. And y varies from -1 to 1, so for lower side y is equal to -1, for the upper edge we have y equal to +1, and this square is considered as uh, lying in z is equal to 0 plane. So h dot dl for the path 1 is equal to h dot dx ax. So it is h dot dx ax because here this is along the x-axis and this is along the x-axis again. These are along the y-axis. So this is h dot dx ax plus h dot dy ay. This is the second path. And this is the third path. Again, this will be h dot dx ax, and this is the fourth path, which is h dot dy ay. So it will be equal to the x component of h, and x component of h is equal to 6xy. So 6xy dx minus 3y square dy. The limit for path 1 is x varies from 2 to 5, and the limit for the second path is y varies from -1 to 1. Again, for the third path, x varies from 5 to 2. So this is again 6xy dx from 5 to 2, and this is the fourth path, and in this path y varies from 1 to -1, and hy is equal to -3y square dy. So this integration will be equal to 3x square y from 2 to 5 minus y cube from -1 to 1 plus 3x square y from 5 to 2 minus y cube from 1 to -1. For this path, y is constant and it is equal to -1, and for this path y is constant and it is equal to +1. So that's why I have written this below these expressions, and we can put these values of y and we can substitute the limits of x and y in all these expressions, and at the end we will get this result. and here this we have a minus 2 and here we have plus 2, so they will be cancelled out, and at the end h dot dl closed line integral will be equal to minus 126 amperes. So let's evaluate the right hand side of the Stokes theorem, which is equal to del cross h dot ds. So let's first evaluate del cross h. So this is ax, ay, az, this is vector operator, and these are the components of h field. And the determinant of this expression can be written as minus partial over partial y 6xy, which is equal to minus 6xaz. So let's evaluate the surface integration. So ds is equal to dx dy az, and del cross h dot ds will be equal to minus 6x dx dy, and its surface integration will be equal to this expression. Y varies from minus 1 to 1, x varies from 2 to 5, and that will be equal to this expression. So let's put these limits, and after putting these limits we will get the answer of minus 126 amperes. So the right hand side of Stokes theorem is also equal to minus 21.6, which is the left hand side of the Stokes theorem. So Stokes theorem is verified in this example, and I hope you have understood the concept of Stokes theorem with the help of this example. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.